Welcome to a journey that takes us from the dawn of human civilization to the cutting-edge frontiers of modern science. Imagine, if you will, a time when the ancients first gazed upon the sun with both awe and trepidation. The sun, our star, has always been a beacon of life, yet it harbors an immense power that can be both nurturing and perilous. As we delve into the heart of the sun, we uncover not just a source of light and warmth, but a dynamic entity capable of unleashing explosive forces beyond our everyday comprehension. Behind its seemingly serene exterior, the sun is a cauldron of boiling plasma. Here, magnetic field lines twist and contort in a relentless dance, storing energy that, when released, can rival the detonation of millions of nuclear bombs. These eruptions, known to us as solar flares and coronal mass ejections, may seem like distant celestial fireworks, but they are anything but benign. They are potent phenomena that can traverse the vast expanse between the sun and earth, threatening to disrupt the very technology upon which our modern existence depends, from satellites to the internet and navigation systems. Let us explore how ancient civilizations perceived these celestial events. Though lacking our contemporary understanding, they were acutely aware of the sun's volatile nature. In the chronicles of ancient China, strange lights illuminating the night sky were documented with meticulous care, often interpreted as omens from the heavens. In Japan and Korea, legends wove these luminous displays into tales of celestial guardians, while Norse mythology saw them as the fiery reflections of divine battles. Even in the Arab and Islamic world, historical records speak of red lights in the sky, forewarnings of significant occurrences, meticulously recorded by scholars of the time. Modern science has since decoded many of these mysteries. With the advent of technology, we have launched satellites like SOHO and SDO, providing us with high-resolution images of the sun's surface, revealing the intricate ballet of plasma and magnetic fields. Our understanding of solar flares has evolved from mere curiosity to a well-defined scientific phenomenon. We have learned that the sun follows an approximately 11-year cycle of activity, marked by fluctuations in sunspots and storm intensity. During periods of peak activity, the probability of Earth-directed eruptions increases significantly. Through the Parker Solar Probe, humanity has for the first time ventured into the sun's outer atmosphere, the solar corona, uncovering secrets of the solar wind and the mechanisms behind massive eruptions that can affect our planet. But why is this important? Because the sun's instability, while a fundamental driver of life on Earth, also presents a formidable risk. Without the solar wind and the magnetic shield it creates, Earth might have been a barren rock adrift in space. Yet this same energy, in a single explosive moment, can pose a global threat. As our reliance on technology deepens, the impact of solar storms becomes ever more pronounced. Our world, intricately linked by satellites, navigation systems, and power grids, is vulnerable. A powerful solar storm can disrupt wireless signals, incapacitate GPS satellites, and force aircraft to reroute. Ships may lose their bearings, and our navigation systems could fail us at critical moments. The power grids that illuminate our cities are more fragile than we might assume. A strong solar storm can induce currents that overwhelm transformers, leading to widespread outages. This was the case in 1989, when a solar storm plunged 6 million Canadians into darkness within minutes. Today, with larger and more interconnected grids, the stakes are even higher. The internet, too, stands at risk. Recent studies suggest that undersea cables carrying data across continents could falter under the stress of a robust solar storm. Imagine a world not only devoid of light, but also disconnected from digital communication, isolated and silent. Consider a scenario akin to the Carrington event of 1859, when a colossal solar eruption lit up the skies as far south as the Caribbean and set telegraph lines ablaze. In today's tech-dependent world, such an event could be catastrophic. Satellites might fail, navigation systems could collapse, and power outages could darken cities for days, if not weeks. The financial systems we rely on could grind to a halt, making simple transactions impossible, and fuel stations might close, leaving vehicles stranded. Hospitals operating under immense pressure would rely heavily on backup generators, and the very fabric of society could be tested. In the aftermath of such a massive solar event, daily life would be irrevocably altered. With the internet down, communication would revert to traditional radio, and people would once again rely on paper maps. Air travel would become precarious, and hospitals would struggle under the weight of increased demand. Food preservation, particularly refrigerated goods, would face challenges, and water distribution might be compromised. While humanity has shown remarkable resilience in the face of adversity, such a calamity would inevitably shift our perspective on the technology we depend on. So, how do we shield ourselves from the sun's capricious fury? While we cannot halt the forces of nature, we can prepare. Governments are developing early warning systems to monitor solar activity, enabling us to anticipate and mitigate the effects of solar storms. Power companies are innovating with more robust transformers to withstand geomagnetically induced currents, while airlines train staff to manage navigation disruptions. On a personal level, preparedness can be both simple and effective. Having a backup battery, a reliable light source, a hand crank radio, and a sufficient water supply can make all the difference during an emergency. Keeping some cash on hand is also prudent in case digital transactions become impossible. Globally, some nations have taken significant steps in emergency preparedness. In the United States, NOAA and NASA continuously observe the sun, operating centers dedicated to analyzing space weather. Some power networks are equipped with systems designed to shield transformers from harmful currents. In Europe, the European Space Agency is advancing the Vigil mission, which aims to offer a new perspective on the sun and provide earlier warnings before solar storms reach Earth. Countries like Japan, Canada, and Finland, situated near regions most affected by solar activity, maintain especially resilient power infrastructures. Looking to the future, a coordinated global effort is essential. New satellites need to be developed to monitor the sun from various angles, and power grids must be redesigned with flexibility in mind, allowing damaged sections to be isolated without causing widespread failures. The development of navigation systems independent of satellites may become a necessity rather than an option. Public awareness is crucial. Many people are unaware that the sun, which we see each day, has the potential to disrupt our civilization within a matter of hours. Educating the public about space weather, creating city-level emergency plans, and fostering a deeper understanding of these cosmic phenomena are vital steps toward a more prepared world. In conclusion, the sun is a source of life, having rendered Earth habitable and providing us with energy for millions of years. Yet it is also an active star, capable of testing our civilization's resilience at any moment. Preparedness, awareness, and modern technology equip us to face this cosmic force. Solar storms are not the end of the world. They remind us that we are part of a vast cosmic system far larger than ourselves. By understanding this message, we can live more safely and plan for a future based on science and preparation rather than relying solely on luck.